All right, hello and welcome to the ninth annual MSc Science Festival and annual celebration of the STEAM disciplines, science, technology, engineering, arts, and mathematics. My name is Catherine, I'll be your host today. And today I'm joined by Steve Marquie. We're gonna talk all about citizen science projects related to weather and agriculture. Hi Steve, so happy to have you joining us today.
Oh, well, it's wonderful to be here. Hello to everyone out there watching. And I hope you have a lot of questions saved up for the end of our live stream today, and that we can answer a few of those for you.
Great, yes. Would love for you all to, throughout the presentation, think about questions you want to ask. If you're joining us on the Zoom webinar, you can use the Q&A function at the bottom of your screen. And if you're joining us on Facebook Live, feel free to ask your questions right in the comments section, and I will be sure to read those off at the end of the presentation. All right, Steve, well, without further ado, I will hand it over to you.
Well, thank you very much, Catherine. Again, I'm Steve Marquie. I'm with the Michigan State University Enviro Weather Program. It's one of the two hats I wear at the university. The other is with the Biosystem and Agricultural Engineering Department, where I teach lab instrumentation classes and also help out with project management. But what we're going to talk about today are weather stations and collecting data. And hopefully you'll be interested in this topic also. And you'd be interested in becoming part of a citizen science effort that engages the public in collecting weather data to share throughout the country. Not everyone is able to afford, nor would you want to, invest $8,000 in a professional grade weather station like you see behind me. This is one of our Enviro weather stations. It's located in an orchard, specifically an apple orchard up near Onekama, Michigan, and they serve the purpose of providing data that drives models that help growers identify the potential for disease and pest outbreaks in their orchard or their crop specific to what they're growing. So exactly what kind of data do you collect and why is it all so important? Well, a station like what you see behind me collects what we consider to be the standard weather parameters, monitoring physical properties such as air temperature, relative humidity, wind speed and wind direction, leaf wetness, soil moisture, soil temperature, solar radiation, and of course, precipitation. Everybody wants to know how much did it rain last night. So we're going to jump right into the presentation today and talk a little bit about citizen science and personal weather stations. So personal weather stations are a really wonderful piece of technology that allows you to collect weather data either through an automated system or a manually monitoring system that will share that information back to the general public through the cloud. And we refer to the cloud as being simply a database in the sky. The MSU Enviro Weather Program that consists of over 100 remote weather stations throughout the state of Michigan and even some over into Wisconsin with the support of the University of Wisconsin-Madison. The Enviro Weather Program collects data from all of those sensors on all of our weather stations. The data goes to a cloud-based storage system. Then the data, based upon the needs of a particular grower, is integrated into some sort of mathematical model that identifies the potential for a disease or a pest outbreak. The grower can then use that decision-making process to determine to what degree do they spray pesticide, limiting it as much as possible so their impact on both the crop and then the environment is minimized. And also, it saves them money. These weather stations are extremely high tech and require some maintenance. Basically, it's in the weather here in Michigan, which isn't too kind to the instrumentation. But we go out on a routine basis and take care of the station and the equipment and make sure it's operating optimally. These research grade weather stations aren't unique to Michigan. Literally every state in the United States that has cash crop agriculture or high yield fruit and vegetable agriculture has such a weather station network that's typically tied to the land grant university for that state. Washington State, Illinois, Iowa, North and South Dakota, Florida, New York State are just a few that have such weather station networks like the MSU Enviro Weather program. So how can you become part of a weather monitoring effort as a citizen scientist? So there are many ways. First, you can become part of the community collaborative rain, hail, snow network known as CocoRAS. It's a program that's based out of Colorado State University and works in conjunction with the National Oceanic Science Observation Program and also the National Weather Service. CocoRAS is a program that will provide you with a manual rain gauge that you'll take daily measurements from and input that data via a phone app into their database, sharing your observation and the time in which it was taken. That becomes the daily precipitation report for your particular location. That data is then shared throughout the country via the database. The other option that you could become involved in personal weather monitoring is through a PWS or personal weather station. We'll talk a little bit more about personal weather stations later on in our presentation. Personal weather stations are instrumented systems that have a little microcomputer. It's connected to the cloud and it sends the data from the instruments to the cloud, and you can log into the cloud and see your own data. And then finally, there's collaborative reporting. This is where, using your personal weather station data, you engage in sharing that information with others, not only other citizen science, those engaged in citizen science, but also people that are interested in looking at the quality of your data and comparing it to the other information collected around the country, such as EnviroWeather. Well, let's talk a little bit about collaborative rain, hail, and snow network, CocoRAS. So Colorado State University created several years ago a fantastic network of over 15,000 private citizens who are dedicating their time to daily monitoring of the precipitation, hail, or snow at their location. Originally, you entered your data on a daily basis by logging into a website. That system has been modernized, and we now have an app that you put on your smartphone, and on a daily basis, you walk out to your rain gauge, read the amount of precipitation that occurred in the last 24 hours, enter that data with a timestamp for your specific location, and then the next important step, empty your rain gauge so you can reset the cycle. That information is stored at a database at Colorado State University and then is compared to data surrounding your location. If there's a problem, you receive a warning that something is slightly amiss and perhaps your precip gauge is plugged up and it needs cleaning or some other maintenance might be required, and you'll get a notice of that. If your data is good, it becomes shared data with the rest of those on the network. This process happens very quickly, and people appreciate the fact that you can share your information in such a timely fashion. So let's talk about personal weather stations. So what exactly is a personal weather station? So personal weather stations are instruments, electronic instruments, that monitor a few of those physical properties that are research grade system monitors, such as wind speed, wind direction, air temperature, relative humidity, and of course, precipitation. The more advanced personal weather stations also monitor solar radiation, soil temperature, soil moisture values, and perhaps solar radiation or leaf wetness. All of this data is then stored on your personal computer at your house and perhaps even displayed on a console that you might have, either physical console or a virtual console that is part of your iPhone or your tablet or your smartphone. Personal weather stations are offered by several companies. Davis Weather Instruments, Spectrum Weather Instruments are two of those such companies. Onset is another one. And of course, Campbell Scientific offers a hobby grade or personal weather station that might work out for your needs. You buy these typically over the internet from a supplier or retailer of such technology. And the cost range is anywhere from a few $100s up to a couple of $1,000s, depending on the number of sensors and the sophistication that you think you might need or want for your particular application. If you're going to have a small garden, you might want a more sophisticated system. But if you're just interested in monitoring a few parameters, you can get away with a nominal investment of somewhere between $300 and $400 for one of these weather stations. Alternatively, if you are an electronic hobbyist, you may find building your own weather station out of an Arduino kit board would be a lot of fun. And there's a lot of internet information that would help you do exactly that. Such an Arduino weather station kit would probably run you somewhere in the vicinity of $100. So there are a lot of options out there, and you need to pick which one will work the best for you. Collaborative monitoring is when you start sharing your data with other people. The easiest way to do this is via the CWOP, or Citizen Weather Observation Program, and MesoWest, which is a clearinghouse, so to speak, of weather data based out of University of Utah and Utah State University. Both organizations collect the data, analyze the data for quality, and then release the data to the general population. We talk a lot about data quality when we're talking about weather monitoring, because people rely on this information for making decisions, and they want to make the best decision based upon the best data possible. Other programs that exist are through Weather Underground, as I mentioned, MesoWest, CocoRa's, Davis Weather Station, Davis WeatherLink system, and soon the MSU Enviro Weather program will have an option for individuals who would like to participate in a private weather station monitoring program where you would be able to use your data with our tools. And I'll share some more about that. If you happen to have your own personal weather station, this is what the dashboard looks like. This is my station. And as you see, I have a little bit of a problem with my wind speed. It's registering 0. And I'll share a little bit about what we're going to do about correcting that problem. This is a typical display of what you would expect for a period of time, maybe 12-hour period of time from such personal weather station. You can also look at the data from your weather station if you're part of a collaborative monitoring program, such as MesoWest. They provide you with historical data. You can look backwards at the data that you provided over a month and assess what the changes have been. And of course, we're all about data. Here's an example of looking backwards at some data from my weather station over the course of a month. As I mentioned, the MSU Enviro Weather Program has a new project that we're soon to be unveiling, where individuals who would like to invest in the personal weather station at their home can do so and use your data, input it into our models, and you can use that decision-making process for your specific location. That's a big advantage if you live in a location that's not necessarily close to one of our existing weather stations. Well, like I said, weather stations out in the field or outside take a lot of abuse. And so we're going to watch a quick video on what happens if you don't happen to have excuse me just for a moment while I get this rolling. Okay. Steve Marquie with MSU Enviro Weather Program. We're going to do a repair on our personal weather station here at our house. We noticed a couple of weeks ago that the wind speed indicator wasn't working. So I discovered that some earlier repairs have failed. Rabbits and squirrels love to chew on these cables. They're very salty to their taste, and they'll chew right through the cable. Of course, these guys weren't doing their job, otherwise they would have chased the rabbits away, I'm sure. They must have been busy that day. We're going to remove these old splices and repair the damaged cable. These splices are called Scotch locks. They were designed for use with telephone wire cable splicing. They're waterproof, very easy to use, and I'll show you how they work. Stick around. So there's not a lot of wind today, but that indicator for our wind speed isn't working, and I suspect it's the splices in the cable. So we're going to take a look at how to go about splicing the wind speed cable. So the first thing we have to do is remove our old splices. We're simply going to splice color to color. So yellow to yellow, green to green, red to red, and the black wire to the black wire. We can simply cut the old splice out. It just so happens I have two old splices. We can discard that, and now it's time to put this back together again. So I already have some of the insulation stripped back, exposing the 4 wires that we're going to splice together from one end of our cable. And now I'm going to do the same to the other end. Next, I'm going to choose one pair. Let's choose the yellow.
We don't have to strip any more insulation off. You simply take the two pair and one end of the Scotch lock is open, and you put the two wires in as far as they'll go inside the Scotch lock. Next, take a pair of slip joint pliers and you're going to crush the connector. There's some glue that is released and seals the end up of the connector, preventing water from running down inside. We'll do this for the other pairs. I like to hold the connector firmly with the pliers while I'm watching the back to make sure that the wires are all the way pushed in, and then compress. Finally, the green, push those two wires in as far as they'll go. And we're done. Connections are all back together again. Everett gives us the seal of approval. We're ready to check our instrument inside the house to make sure it's giving us the wind instrument data that we expect.
Oops, wrong way. Okay, so you get an idea that even if you have your own personal weather station, you may have to do some basic maintenance from time to time on your equipment to make sure that your data is good. Because after all, you want to share this data and people want to rely on the information they're getting from you. That's all I have. Anybody have any questions, please let me know.
Awesome. Thanks so much, Steve. I just downloaded the CocoRoz app on my phone. I'm ready to get started.
Super. Please reach out if you're interested in CocoRoz. Reach out to them. They'll provide you with a precipitation gauge that you can mount, and they provide you with all the instructions necessary on how to get it installed at your house.
Awesome. Well, thanks for everyone who's tuned in right now. We're running out of time, but we can take a question or two. If you're joining us on Zoom, feel free to use that Q&A function at the bottom of your screen. If you're joining us on the Facebook live stream, feel free to ask your questions right in the comments section. So Steve, just a quick question just to kick it off. I'm hoping you could talk about why this matters. How does weather impact our crops?
Weather impacts everything, let alone our crops, but weather impacts the crops because certain insects, pests, and diseases actually become more abundant or less abundant based on particular environmental or weather conditions. We monitor that information. We can identify what the potential for an outbreak of that disease is based upon past data. Years have gone by of monitoring, for example, apple scab, which is a fungus that affects apples, especially here in Michigan. The last thing you want to do is bite into an apple that's nasty and has fungus in it. By monitoring that potential for the disease outbreak, we can determine when is the best time to spray the least amount of chemical.
Great. And so I also have another question. The new MSU Enviro weather, there we go, program that you all are kicking off. Are there certain locations in Michigan where you're hoping that people sign up for this program from?
If you take a look at our map of the state for Enviro weather, all of the dots are our existing stations. And what would be great is if you happen to live in one of the areas not supported with one of the research grade stations, we'd love to have a partnership with someone that would like to put up their personal weather station. Michigan has a lot of microclimates, especially on the west side of the state. If you happen to live in one of these microclimates that we don't currently have an Enviro weather station, that would be an ideal partnership.
Great. Well, unfortunately, we're out of time, but Steve, thank you so much again for joining us. If people want to learn more about all of these programs, where can they go to learn more?
First stop, enviroweather.msu.edu. Also, if you'd like to drop me an email, please do so, wb9tow@msu.edu.
Great. Thanks again. I know I'll certainly be checking all of this out. And thank you again for everyone who tuned in. Be sure to check out the rest of the programs today and throughout the rest of the month of April. You can view all of our programs and learn more at sciencefestival.msu.edu. Thanks so much, everyone. Take care.
Bye, everyone.